Right, hey everyone, welcome back. So, I guess a little bit of context is important here. So, last year, we ended up doing a review week at about halfway through the course. And the logic of this being that there was going to be some people who either missed a session or had questions or whatever, right? And because we move fairly quickly through a lot of concepts, even at a high level, it makes sense to step back for a minute and give everyone a chance to ask questions, follow up on where things are. In case anyone is wondering what next week will be on, next week is on data structures. So we're just taking a minute to step back and go through everything, answer any questions there are. So, but yeah, so I guess I'm going to go through the first few weeks we have, and if there are any questions at any point, feel free to say something. And yeah, we'll happily stop and answer them. All right, so let me actually start with week two's materials real quick, because that's probably going to do a little bit of a better job, because the very first week was just an introduction to the course and what it's about. So for week one, we did the introduction on what this course was, and we wrote like a couple lines of code. For week two, what we did is we went through functions, we went through I/O, so specifically which stands for input output. So user input, user output, or system input, system output. Kind of things like the user enters their name into the system, or the system prints out the name of a file, right? Or writes to a file, right? That's an example of that. We also covered variables, which at a high level are just an abstraction that we use in order to store data, a data value specifically. So I'm going to jump through a little bit of this, and this is week two here, where we're at. I'm going to move relatively quickly through this. Considering we've already gone through it once, but just enough to like touch on it at a high level, and yeah. So a little recap, right? So what is a variable exactly? So it's an abstract store of a value. Okay. So for example, here I've defined my variable name as A, and I've set the value to 1. For here I've defined as B, and I've set the value to 2. Your assignment is done with an equals operator. So the way this works is variable name on the left, the value on the right, equals operator in the middle. And you can also assign them to each other, such as what we see with C equals A. Value printed on this should be 1. Okay. So quick little introduction on this, and we'll touch on this a little bit more as we go through more review of this, but there's also types for a variable, right? So like, for example, our first one here is an int, right? 1 is an int, 2 is an int, 3 is an int. 2.5 would be something like a float, right? Or 3.14, right? So yeah, okay. Pi is a string being a series of characters, right? Okay. 1.0 is a float, right? So basically, if you were trying to figure out how to determine the difference between the float and int, ints are whole numbers, floats are not. Floats are going to include things like decimals, for example. But yeah. Okay, and here's a fun one. So a list, and in some languages, this is referred to as an array. So I may have used it interchangeably previously in the lesson, but they're effectively referring to the same thing here. But what this is it's just going to, it's going to hold whatever you place in it, right? So for example, here it is holding a bunch of ints, right? There's nothing here that stops us from putting, say, strings in here, or floats, or classes that we, briefly touched upon last week. All right. So, like for example, there's also a function you can use here, which is the type function. This is more for like an example of showing how you would use this. The odds of you using this in regular use case, in most languages, fairly unlikely. You might use it in certain situations where, like, for example, you're getting an input from a user and you don't know exactly what to do with it. But a good chunk of the time, you should at least be able to infer what the type's going to be from the input, right? I think user input is the key one on this. User input and possibly data that comes over a network. So, for example, this first one here, that's going to be an int, that's going to be a float. Wait, sorry, that's going to be a string. That's going to be a float. That's going to be a list. And also, obligatory disclaimer, if I say something incorrect, please do let me know, because I am human, and there's a decent chance I'm going to make a mistake somewhere. Okay. We've kind of used this a little bit in the last few worksheets. We've also kind of touched upon this indirectly. We've kind of used this. So, like, for example, sometimes you'll want to convert a type, right? And my favorite example of it is if I add 1 and 1, and they're strings, I'm going to get a string that contains 1, 1, but that's 11. If I add integers together, I'm going to actually do the mathematical operation, which is going to result in me getting a value of 2. Right? Which is why this here is actually going to have a different result, right? So this one here is going to be 2, and this one here is going to be 11. So more effectively, it's going to be a string that contains 2 1s, and we as humans would read that as 11. To the computer, it's just 2 11s that are next to each other. All right. Let me check the Discord real quick, see if anyone has a question on any of this at any point. All right. All right. Are there any questions on any of this so far? I know we're kind of moving quickly through like a review of a lot of it, but I know we're kind of moving.
Currently.
Okay, cool. All right. So I guess I'll just keep going real quick through this. So input output, right? User input, user output, system input, system output. So in the case of Python, all inputs are going to be strings. So this is going to return a string, right? So the function input, when it is called, is going to return a string. It's going to return a string that contains the input that the user specified, which is fairly useful, right? So we can get some input from the user. We won't know what we're going to have to do after that point is we're going to have to infer what exactly the type is, right? Like, do we want it to be a string? Do we want it to be an int? Are we accepting floats from the user, right? We're going to have to convert it after we've received it to whatever value we're working with, right? Which kind of goes back to where is my typecasting? Yeah, which kind of goes a little bit back to this, right? It's like, for example, it's like if I were to call the str function, there's also a function here called int, which could use to cast it over as well. There's a few different ways to convert that over to the respective value we want to work with. I'm using int as an example here. But yeah, all in all, fairly useful. Different languages are going to have different ways to handle this. Some languages are not going to There are some languages that are not going to return a string back to you, but in the case of Python, we're going to. But, you know, just for context, if we come from another language. Yeah, there you go. Okay. This is a fun one. So function basics, right? Or just functions in general, right? So an example of one we've used really heavily in this course so far is the print function. We've used it to show what the program is doing, what the value is, and to get an idea on exactly what value has been returned, right? Or what is going on. So, like for example, in this 1 + 1, this is going to print 2 for us. So there's a lot of built-in functions, and print is an example of a built-in. There are, in the case of writing our own, and I'm actually going to jump ahead to the next one because this will do a much better job on explaining this. But in the case of implementing our own, my hand just stopped working. Brilliant. In the case of implementing our own, we're going to have several parts to it, right? So we have def, which is the keyword that actually is going to define the function, or as it is technically referred to in Python, method. Okay. We're going to have some parameters, and we may also have types. The types are technically optional. I'd encourage them to be used, but you don't have to. You know, they're an option. They're optional in this case. They are optional in this language. So, for example, we have a method named add, and it has 2 parameters, which are a and b. A and b both are ints. Cool. And we know it's going to return int by the return type specified over here. Okay. And then we have a return. The return is actually the keyword we use to specify what value is going to be returned by the function. All right. Also, fun note, if you do call return inside of a loop, which if you do call return inside of a loop, you will also end the execution of that loop. A fun little bit of information. It's because what it does is it exits the function immediately. It's going to exit whatever you are doing in there. There are some nuances and some exceptions to that, but for the purposes of this, yeah, it's going to exit what you're doing. And of course, everything that's indented under here is referred to colloquially just the function body. This is going to be any operations, any logic that you would want to do here, right? So like, for example, let's say I had a variable for storing the value of a plus b, and let's say I made it c. So let's say hypothetically I had c equals a plus b, and then I returned c. Okay. In that case, that's part of our function body. Cool. So, yeah. Some languages are going to have a slightly different implementation of this. A couple of key things that'll differ from language to language. For those who would like to learn a little bit more about this area, just programming in general. This indication here on the return type differs a lot between languages. The way you define the function depends on some languages. Some here will be func, some here will be function. Some are going to have def like Python here. And you may find slightly different handling on things like types, like how you define the type. But in general, the overall structure of this is very similar from language to language. It's just a fun little bit of side trivia for those of you who would like to dig into this more and use it in other areas. Yep, as said earlier, types are not always needed. So here we don't have a type. Should we have a type? Probably, but we don't. You also don't always need a return. In fact, on a lot of cases, you don't want to have a return. What this is referred to as a void function, and this is just going to not return any data back. So you would use something like this. You would use a void function if you wanted a function to do something, but you don't want to get a value back. Printing an input back to a user is a great example of that. I want it to print a string back to the user with some formatting. I don't necessarily need to get a value back in this scenario. Okay. It's like, for example, here we are getting the, so example here, we are getting the input from the user, we are assigning it to the variable name, and then we are calling say hi name. Okay. And what this is going to do is this is just going to pass this, the name variable, into this function, and we're going to get the I'm watching you type user provided name, which is technically a little creepy the way it's written, but hey, whatever. That is what that function will do. My leg is broken. Brilliant. All right. So, don't write this way, but just using it as an example. So if you wanted to really mess with this, we could have a function where or a method where we pass the value into another one into another one. So what this is going to do is it's going to pass 3 and 4 into the add method. Okay, and that should be 7. And then it's going to do 2 plus 7, with 2 being the value of A and 7 being the value of B, so that'll return 9. And then it's going to pass in 1 as the value for A, and 9 is the value for B, and it's going to return 10, effectively making this print 10. A lot easier way to write this would be to set these to variables, like the return values to variables. I advise people not to do this exactly where that you chain together, let's see, 1, 2, 3, technically 4 functions together. Makes it very difficult to read. But that's a good example. All right. Okay. Let me jump on to week 3 real quick. For some strange reason, that slide took a minute to load on my screen. Probably an issue on my side. So, all right. So before we go on to reviewing week's 3 materials, does anyone have any questions on that, on week 2? The functions, the variables, just the general handling of user input-output. I see a hand raised. Go for it.
Just fixing stuff on mine. Referring to me.
Let me turn up my audio. Oh, that is already off. Okay. I apologize, I couldn't hear you.
I was just fixing some issues with mine. I just joined.
Oh, I got you. Okay, cool. All right. I don't see any questions there. I don't see any questions in the... Yeah, I don't see any questions. All right, cool. If there are any at any point, feel free to stop me and I'll happily add in or explain. All right. This is loops and conditions. So this is the fun part. This is how we actually get to determine what our program does in terms of flow. If something is true, we want to make it perform a specific action. Or if it's not true, we don't want to make it perform a specific action, right? So we refer to this as conditions here, or just conditional logic. So how does a condition work? And I guess going back to some questions that have occurred during this lesson. So the way this is working is if, and then you're going to have a condition here. So this could be 3 less than 4. This could be comparing, like, so for example, doing comparisons on ints. It could be doing a less than or greater than operation. 3 is less than 4, for example. That will always be true. Or 2 strings where one string is dog and the other string is cat. Those two are never going to be equal. So if you were to set an equal condition on them here, or a quality comparison on them here, you are going to end up with this condition always being false, and which will cause your else condition to run. And I guess there's also a little bit of context that's needed here. So when you perform those type of comparisons, let me see if I can find a good one here. Gonna jump ahead real quick to see if I can find that. Okay. So what's going on under the hood is when you perform these type of comparisons, you are actually getting a Boolean back, right? So what this is doing is this is effective 1 equals 1 is effectively returning a Boolean for you. It's returning a Boolean of the value true, which is a type of variable. Same deal with this, right? 0.99 is less than 1. This is also true. 1 is greater than 1. Not true. That will be false. That's going to return a Boolean that equals false. This technically means, because of the way that works, you can use a variable in this place, you can use the condition in this place, or you can just shortcut the whole thing and just put true or false if you choose to make it execute, and that will work completely fine. Adding that little bit of context there because a question came up during one of the workshops and figured it was worth explaining. Yeah. So yeah, Boolean is its own data type. The reason we did not cover it as a data type originally whenever we covered variable types is because it's one of those, we can, but it's throwing a lot of information at once. And in order to explain that there is a Boolean type, you have to explain what a conditional is, and that was too much information to cover in the same week. But yeah, to connect these pieces together, there you go. Okay. That's what you can do comparisons on a number of things. So you can compare ints if you wanted to. We're using ints in this. You can compare strings. So for example, equals equals. Okay, this is an equality comparison. So it has to equal, the value on the left has to equal the value on the right. Less than, the value on the left has to be less than the value on the right. Greater than, same deal, just the reverse of that. So this value needs to be greater than this. Greater than or equal to, as well as less than or equal to, which is just this character here with an equal sign right here. Same deal. It has to be greater than or equal to fire in order for it to work. The difference between these two seems very small, but let's say, for example, you are wanting to run something X number of times, and you are running a loop. If you say, I want to do this less than 5, it's going to execute however many times. Let's say you start at 0, you're going to go 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay, so that's going to execute 5 times in itself. However, the minute you make it less than or equal to, it's going to execute 6 times, which is probably not what you wanted if you were doing a for loop and you were saying, I want to execute 5 times. That's the reason that whenever we write for loops like that, we'll typically use a symbol like that. We typically don't use a greater than or equal to or less than or equal to in those scenarios. Oh yeah, technically, if you wish, you can also do this. So you could also see, is this variable or this value I have, is it of type string? And this will also return a Boolean back. So you could make something be like, oh, did the user give me an int? Okay, I believe the user gave me an int. Please perform this following condition of logic. All right. Couple examples here, but I'm going to skip right through this one. Match case, which I'm realizing we probably need to actually go back through and add into worksheet examples at some point because it's not actually in any of our worksheet examples. But we want multiple conditions, you use a match case, commonly referred to as a switch case in other languages. So the way this works is you have your variable here. So you have a match keyword, you have a variable that you want to do the check on, then you have a case keyword, and for each value you expect to match, you would provide it, with the underscore being the default value. All right, let's do loops really fast on this. Okay. So what is a loop? A loop is a piece of code that's just going to continue to execute again and again and again, right? So for example, I want to print values from 0 to 100. Well, this is really tedious. And this isn't much better, to be honest with you. So we use a for loop in this scenario. We use a for loop because we know when it's going to end, right? We know we want to stop. We want to stop once we have printed the value 100 in this scenario, right? So we have our start, which is our definition of our loop. Are we on our last item? No. we're not on our last item, then continue the loop. We are on the last item, exit the loop. So here's a fun one. So for example, here we have here we have a list of strings, which is cat, window, and defenestrate. Yes, which if someone was to have some fun, they can look up what that means. But so for W in words, so what this is going to be is we're going to go through this list, and for each execution of the list, W is going to be assigned the respective word, right? So cat, window, defenestrate. So if we run this code, it's going to print all these out in the list real quick. Okay, while loops, same deal. They just execute until the condition you had is no longer true, right? So here's a good code example of this. As long as x does not equal secret, this code will continue to run. Okay. So what this means is, in this example, we are taking the input from the user, and then we are going through, and once we have the correct value, we'll notify them that we have the right value. Otherwise, we'll tell them it's not. But by doing this, we are capturing the input from the user, we are setting it to x, which means that eventually this will no longer be the case. So eventually the loop execution will end when that happens. I see my foot has broken. Lovely. All right, so for a for loop, you know how whenever you're working running it, you know how many times the loop will run. And you're going to run through a list of or if you're running through a list of unknown length, but it's finite. Like I know eventually that this list is going to end. I don't know when it's going to end, but I know eventually it's going to end. If I don't know when this condition is going to end, then I would use a while loop. And a while loop is going to be very commonly used in something like a game that you want to keep running forever, or at least until the user decides to actually go through and exit it, or something like an operating system, or I don't know, maybe something like a web server. There are more than a few examples where you would, like basically if you want it to run forever, you'd use a while loop. You could also use it in situations where you don't know how long it's going to run, but you know eventually it should end, right? Technically speaking, and I'm not saying you should do this, but everything you can do with a while loop, you can technically implement in a for loop. I'm not saying you should, because your code's going to be a lot cleaner if you don't do that, but you technically can. There's nothing stopping you in a while loop from going through a list and pulling the respective item and then using that item and then exiting once you're at the end of the list. It's not very clean, but you can technically do it. And I technically have done it on a couple occasions where I'm having to iterate through like 3 lists of data at once, but I don't recommend doing that. All right. We got any questions on this? Moving relatively quickly through here because it's a review session. All right, let's continue on, shall we? Okay. And this gets back to last week's, which is probably worth going through just again anyways, because we started very late due to technical issues on my side, and for anyone listening, I sincerely apologize for that. So, week 4, last week, was objects and classes. Okay, so, and I'm just gonna skip through these first few slides since we've literally just gone through them. Okay, so what is an object and why would we use it? So, I'm actually gonna skip this disclaimer. But the TLDR of it is objects are very opinionated ways to program, and everyone's going to have a different opinion, and we're just going to explain how they work here. We're not going to get into the design paradigm or ethos of it. Okay. Okay, there we go. All right, so what is an object? So basically, it's a mechanism for storing related variables and functions of code. So what you would use an object for is you would use it to store groups of information, right? So for example, I have some variables, right? I want to store x equals 20, y equals 20, okay? And I have a function that I want to contain this logic on, which is the add function. In this case, I want to do self.x plus self.y. Okay, so to create a new example object, we're going to call example. And please pretend this is my example here, my example.x. So it would effectively end up printing 20 here. Okay. Obligatory disclaimer, the errors from last week are still on this slide. But if you look at the slides that are linked in the on the in the Discord, then they will be correct. So, in fact, I actually really encourage that week's worksheet because because classes are one of those things that you don't really completely understand until you've actually sat down and written out yourself, written logic for, and have gone through and applied, right? Because it's very easy to conceptualize how they should work in theory, but the way they work in terms of how they impact your program structure is so wildly different from just sticking your functions or methods in a file that it can be surprising on how much it changes the structure of your program. All right. So, yeah. So, and I would actually recommend that even if you consider yourself fairly knowledgeable with it, just because there's a lot of, speaking from personal experience here with programming, it's very easy to be like, okay, I understand variables, I understand functions, I understand how to do loops and if conditions and all this. And then you look at classes and you're like, I don't need this. Speaking from personal experience, yeah, sometimes you do. And it's nice to be able to sit down and work through it. Like when I originally did my programming courses, like my computer science classes for my undergraduate, classes were the one moment where I actually had to step back and actually read up on the material a lot closer and review exactly what was going on. I've been a programmer in my spare time for like 2-3 years prior to that. All right, so I guess on the note of why should I even care, right? So technically speaking, everything you can do here, you can do with classes, you can do without them, at least in the case of Python here. You can perform any of the function operations you want to, any of the logic operations you want to. It's more of a question of organization, and it's more of an issue whenever you want to interface with other people's libraries or external code. There's a lot of external code, at least in, had to check the year, wow, okay. At least in 2025, a lot of external code in Python is actually going to depend on a class. So if you want to use like a library, you probably have to know how it works. All right. It's also slightly more clean. So like, for example, see this block of logic in the bottom corner here, and versus the top right over here. My leg is just going to be broken for half of this lesson. Well, it happens. Anyways, so let's break down what this is. So basically, the way you define a class, you have a class keyword, which is referred to as which is class, and you're going to have the class keyword, and then you're going to have the name of the class, right? And if you want to store variables, you would store them in here, right? X equals 20, y equals 10, for example. You can then define functions with the def keyword, and you would pass in self, so that way you can refer to your instance of the class. So what this means is, like, for example, when I create a new instance, like down here, it will create, what will happen is if I were to reference self within our function here, it's going to refer to that instance of the object we have created. So for example, if I created a new instance of example, and I do a operation to add the values, or to change the value of x, then it's only going to change that instance. Okay. We also briefly covered inheritance. We're not covering any, we're not going to get super in-depth into override on here, but at a very high level on this, we're going to reuse a class. So on the right side, we have our superclass, which is the class that our child class is going to inherit from. So what this is going to do is we're going to have class animal, and it's going to have one method called headpat, right? And we're going to create a class that inherits from animal. In this case, it is cat. Okay. So over here, by the way, yes, this is not technically needed. For the curious, yes, you do not actually need this here. But what we're going to do is we're going to define the class that we inherit from, which is animal, and we're going to just overwrite the respective method here. So we're going to make this now print meow. All right. Okay. And that's pretty much everything we've covered up to this point, covered in a really quick, condensed review. So I guess let me leave this open to questions. Does anyone have any questions on anything? Any questions in the streams currently?
Someone has asked, where can we find the slides for week 4?
Yes, so they are currently tucked away in the intro to CS forum. And I'm going to guess that, yes, if I send a ping inside of there, it does not work. So I'm just gonna, can I create a link on this? Probably not inside of VR. Oh, nope, I can. Copy link. And paste. For the curious, just dropped it in the chat. But yeah, that's a really good question, and I guess the intro to CS ping is currently not working in there. So yeah, that would basically be what happened. The worksheet is also linked there. Yeah, my apologies for that. Do we have any other questions?
I have a small one.
Go for it.
Do you want to explain the difference between a double equals equality and an is equality?
That's a good. We could. I use it so rarely, I'm actually afraid of making a mistake. So if you want to chime in on it, feel free.
So within Python, if I remember correctly, let me check. So with an equality of equals, you are checking the value of the content. So if it, let's say an array, if the arrays have the same content inside of them, then equals will be correct. But an is checking for the reference and pointer in memory. So if you have two different instances of a class, they will not be equal with an is.
You would use for which you would use for if my memory serves me correctly, you would use to verify that you are referring to the same copy of the object in memory, and you could use that for implementing something like a singleton pattern, correct?
Yep.
Yep. For those who don't know, for context, a singleton pattern in programming is where you have a single object, and that object is storing whatever data that you expect to have constant throughout your program. It's a fairly common method. It has its own trade-offs in terms of design, but it's a fairly common method, so that way you can have the same global or semi-global copy of variables and state across your application. But yeah, very useful, very important. There's not really a whole lot of use case to implement it in the worksheets because they're not really big enough or complex enough to do that. But if you're working on something like a game or a much larger project where you have like 20, 30 files and you want to have the variables, those variables accessible across everything, if it sounds like a good way in order to make your code impossible to read, that is correct. Be mindful of what you put in that object. You can use that. But yeah. Thank you, Star. It's a really important call out. All right. What else do we got? All right. Well, we don't have anything. I guess we're good to call the stream there. Happy to answer any questions there may be in the within the channel. And yeah, if you've missed a previous lesson, this is probably a fairly good one to go through if you want to just see what the high level concept is. But yeah, I guess have a good one, y'all. See you next week.